So to talk about insulation and home insulation, we need to talk about U values and R values. Now, U values are basically the coefficient of heat conductivity, how conductive it is, how much heat is let through. Basically measuring a material's ability to conduct heat. We're looking at the power, the rate of energy transfer per area and per temperature. Now in metric, that's watts per meter squared degrees Celsius. In the US, we can think of it as BTUs, which is a unit of energy. Energy per square foot, per hour, and per degree Fahrenheit. So even looking at this, we can see that how much energy goes through for a certain area in a certain amount of time, for a certain amount of temperature difference, and all those things are going to affect how much heat actually flows through. So that's the U value, how conductive it is. More often we're talking about R values and how resistive it is, because usually we want to prevent the transfer of energy through a wall. So this is measuring the material's ability to resist heat flow through it. And they're the reciprocals of each other. The R value is the reciprocal of the U value. And if we want to get a bulk R value or R value of many materials, you simply just add them up. So for example, let's look at our wall here. We have brick on the outside. There's an inch of airspace. We have foil-faced polyisocyanurate, fancy plastic insulation there, fiberglass batting, which is another type of insulation, and then finally 5-inch drywall on the inside. All these different things have different R values because they each individually resist heat different amounts. So to get the total wall cavity R value, that would be 0.56 for the drywall, plus 19 for the fiberglass bat, which does most of the work here, plus 7.2 for the rigid board insulation. You got 0.17 for the airspace and 0.8 for the brick, for a total R value of, add them all up, 27.7. Now, if we want to know what the R value was through the at the stud location, because in your walls there are studs, the actual 2x4 framing, and then there's a space usually filled with insulation. So basically right here we still have the brick, we still have the airspace, we still have the polyisocyanurate, which is basically rigid board insulation, but instead of the fiberglass we have the wood stud. So we'd have all the same values, except instead of R19 we'll replace that with the 6.88 for the 2x6 in this case. So that gives us an R value of 15.6, which is less than what the fiberglass would be. That usually doesn't account for a large amount of area. So again, R values basically add up across whatever materials are there. Sometimes you'll have it's an R3 per inch. So you'll have to take into consideration that it's a 2x6. So this is actually 5.5 inches of fiberglass batting. So you might have to look at what the R values are per inch, but you basically just add them up. And that's the reciprocal of the U value, if you wanted to know that.